Hello everyone, once again welcome you all to my YouTube channel Physics with Dr. Sanjay Bhargav. Hope you have understood our first video on vectors where we introduced scalars, vectors, what are the different types of vectors. Then we introduced the different ways of vector addition through triangle law, parallelogram law of vector addition and the polygon law of vector addition. We also provided an insight to how vectors are subtracted in video number 1, that is vector 1. In this video today, we are going to understand about resolution of a vector. Then we are going to study about multiplication of two vectors through a scalar product, the vector product. Then we are supposed to study about different properties of the scalar and the cross product. Then we are going to study about the applications of the product. Then in the last we will introduce the concept of relative velocity. So we begin this lecture with resolution of vector. Now the question is, what is resolution? The process of splitting of a vector into two or more components is called resolution. Then we come across another word called resolution, rectangular resolution. The process of splitting of a vector into two or more components at right angles to each other is called rectangular resolution of a vector, and the component vectors are then called as rectangular components. So one may feel resolution is exactly opposite to that of addition. In addition, we were converting or adding two vectors to obtain a resultant vector, and in resolution we are just dividing a single vector into two or more components. So we consider a vector A in the XOY plane. So this is x-axis, this is y-axis, this represents the XOY plane, and this is vector A, making an angle theta with the horizontal. Now this can be written as the x component and this could be written as the y component. Now there is a, using the triangle law, in the triangle OPQ, what I can write is OQ vector plus QP vector as OP. OP is represented by A vector, and then OQ is represented by AX and QP is represented by AY. Here AX and AY are called as the two rectangular components of a vector A. Then in the triangle OPQ, we are in a position to calculate, that is the triangle OPQ. We can calculate sine theta and we can cos theta also. In sine theta it would be perpendicular upon hypotenuse, while in cos theta it would be base upon hypotenuse. So we have sine theta as PQ upon OP, which may be equal to AY upon A, or AY would be given as A sine theta. Similarly, cos theta gives OQ upon OP, so it would be AX upon A, so AX would be equal to A cos theta. Now A vector is equal to AX plus AY, so I can write it as I of AX plus J of AY. Now AX ka square plus AY ka square would be equal to A square into sine square plus cos square theta, which is 1. So A can be written as, that is magnitude of A vector can be written as under root of AX square plus AY square. Now based on our understanding, let us try this example. The X and Y component of A vector are 4 and 6 meter respectively. The X and Y components of A vector plus B vector are 10 and 9 meter respectively. For B vector, calculate its X and Y components, its length and the angle made by the B vector with X axis, that is you need to determine the direction of B vector. Let us assume A vector as I of AX plus J of AY, B vector as I of BX plus J of BY. Now according to the question, AX is 4 and AY is 6. So I have A vector as 4i cap plus 6j cap. According to question, the x component of a vector plus b vector, that is ax plus bx is 10, and the y component is ay plus by is equal to 9. Substitute the values of ax and ay to obtain the values of bx and by. Bx comes out to be 6 and by comes out to be 3. So I have b vector as 6i cap plus 3j cap. So we have the first answer. The x component of b vector is equal to 6 and y component is 3. Now how do we calculate the length? Length would be calculated as under root of bx ka square plus by ka square, and that is under root 45 meter. Then what would be the angle made? Angle made by the b vector would be given by tangent alpha would be equal to the ratio of y component to the x component. So it would be equal to 3 upon 6, that is half. The angle made by the b vector with respect to the horizontal is alpha, and it is given by tangent inverse half. Now we want to understand how are the two vectors multiplied. There are two ways of vector multiplication. The first one is the scalar product or the dot product of two vectors. Now multiplication of two vectors such that resultant is a scalar is called scalar or dot product. That means you are multiplying two vectors, and after multiplication whatever you get is a scalar. The scalar product is numerically equal to the product of magnitude of the two vectors and cosine of the angle between the two vectors. That is, how do I define the dot product? A vector dot b vector is equal to magnitude of a, magnitude of b, and cos of angle between the two vectors. So here we have a vector a represented by PR, another vector b as here, and the angle between the two vectors is theta. Let us provide a geometrical interpretation to the dot product. Here a dot b can be written as a into b cos theta. Now if I resolve b, then this component of b would be equal to b cos theta, and the perpendicular component would be equal to b sin theta. So what is b cos theta? It is component of b vector along a. So I can write as a into magnitude of component of b vector in the direction of a vector. Similarly, a dot b can be written as a cos theta into b. So if I resolve a, then in this direction the component of a would be a cos theta. So I can write it as b into magnitude of component of a vector in the direction of b vector. Now let us study some important properties of the dot product. The first one, the dot product obeys commutative law. A dot b is equal to b dot a. That is, a into b cos theta is equal to b into a cos theta. The dot product obeys the distributive law. A vector dot b plus c vector must be equal to a dot b plus a dot c. The dot product of a vector with itself is equal to square of the vector magnitude. A dot a is a cos 0 would be equal to a square. So a can be written as under root of a dot a. The dot product of two perpendicular vectors is 0. If a vector and b vectors are perpendicular to each other, then what happens? The angle between the two vectors is 90 and cos of 90 would be 0. So a dot b would come out to be 0. So how to prove that two vectors are perpendicular? So I say two vectors are perpendicular orthogonal to each other only when their vector product is, where their dot product is 0. So if a dot b comes out to be 0, then necessarily a vector is perpendicular to b vector. If the dot product of two vectors is equal to the positive product of magnitude of individual vectors, then the vectors are parallel to each other. For parallel vectors, theta is supposed to be 0 and cos 0 is 1. So a dot b can be written as a into b, and this is the maximum value of it. So if the dot product is equal to magnitude of a and magnitude of b, then the vectors are said to be parallel. if the dot product of two vectors is equal to the negative product of magnitude of the individual vectors, then the vectors are anti-parallel to each other. For anti-parallel vectors, theta is 180. A dot B is AB cos pi. And what is the value of cos pi? Cos 180 is -1. So I get minus AB. This is the minimum value. If I obtain the maximum value, they are parallel. If I obtain the minimum value, they are anti-parallel. The dot product can also be used to calculate the angle between the two vectors. Cos theta is A dot B upon A into B. So dot product can also be utilized to calculate what would be the angle between the two vectors. Now let us learn how to calculate dot product in terms of Cartesian coordinate system. For that, I assume A vector as I of x, ax plus j of ay plus k of az, B vector as I of bx plus j of by plus k of bz. I am supposed to write A vector dot B vector, then I can write A vector here and B vector here. The first term would have multiplication with the three remaining terms, so we'll have 3 into 3, 9 terms. Ax bx I dot I, ax by I dot j, ax bz I dot k. Then you multiply the second term, so I have ay by j dot j, ay bx j dot I, and ay bz j dot k. Then multiply the third term with the remaining three, az bz k dot k plus az bx k dot I plus az by is k dot j. Here I dot I, j dot j and k dot k would be 1. The reason is angle between the same directions would be 0, cos 0 would be 1. But when it comes to I dot j is equal to j dot I is equal to I dot k is equal to k dot I is equal to j dot k is equal to k dot j is equal to 0. Why is this 0? The reason is the dot product of two perpendicular vectors is 0. Why is I dot j and j dot I equal? Because dot product obeys commutative law. So all terms here would be equal to 0. Only the three terms would exist here. So A dot B can be written as ax bx plus ay by plus az bz. All these results can be summarized in this table. I dot I would be 1, I dot j would be 0, I dot k would be 0, j dot I would be 0, j dot j would be 1, j dot k would be 0. Similarly, k dot I would be 0. Similarly, k dot j is also 0 and k dot k is 1. So all results of the dot product summarized in this rectangular table. Another type of product is called as either the vector product or the cross product. Now, what is vector product? The multiplication of two vectors such that the resultant is a vector is called vector product. So in the earlier scalar product, the resultant was a scalar, and here the resultant is a vector. How do I define my vector product? As C vector is equal to A vector cross B vector equals A B sine theta n cap. That means after multiplication I obtain a vector whose direction would be given by n cap. What is the magnitude of C? It would be given by magnitude of A cross B, and that is A B sine theta. What is theta? Theta is the angle between the two vectors A and B. What does n cap provide? N cap provides me the direction of C vector. C vector is perpendicular to the plane containing A vector and B vector. Now, what would be the direction of the resultant obtained in the cross product? So we write three statements to determine the direction of resultant obtained in the cross product. What does it say? The direction of a vector product is perpendicular to the plane containing the two vectors. Other than this, we have right hand thumb rule. What does it say? Curl the fingers of your right hand in the direction of cross product, then the thumb points in the direction of resultant. So I can curl my fingers in the direction of cross product, then thumb gives me the direction of resultant vector. So if I have A cross B, I must curl my fingers in the direction A to B. Then whatever is the direction of thumb, the same would be the direction of resultant obtained in the cross product. Then we have right hand screw rule. So what does it say? If the head of the screw is rotated in the direction of cross product, like I hold the screw like this, with the help of a screwdriver I am rotating it in the direction of cross product, then whatever is the direction of motion of tip of the screw will provide me the direction of resultant. Remember, you have to rotate the screw with the help of a screwdriver in the direction of cross product. Then the direction of motion of tip of the screw will provide me the direction of resultant. Now let us understand some important properties of the cross product. So hope you all have understood how to calculate the direction or how to determine the direction of the resultant. It can be done either with the help of right hand screw rule or with the help of right hand thumb rule. Now what are the properties of the cross product? The first property says vector product is non-commutative. That means it does not obey commutative law. So A cross B is never equal to B cross A. Though their magnitudes may be same, but their directions are opposite. So we can write A cross B is equal to minus of B cross A. What does the negative sign show? Both are opposite in direction, but their magnitudes are equal and equal to AB sine theta. Vector product obeys distributive law when the order of vectors is maintained. So here we can write A vector cross B vector plus C vector would be equal to A cross B plus A cross C. You have to maintain order. Whichever vector comes first has to come first only. The cross product of vectors with itself gives 0 vector. So magnitude of A cross B is AB sine theta. So if I write A equals B, then A cross A magnitude would be AA sine 0, which is 0. So I can write cross product of the vector with itself would be equal to 0. So I obtain cross product of a vector with itself as 0 vector. The vector product of two parallel, anti-parallel or collinear vectors is 0 vector. Parallel means theta 0, sine 0 would be 0. Anti-parallel, theta is 180, sine 180 would be 0. Collinear means theta 0. In all the cases, the resultant would come out to be 0. So for parallel vectors, theta is 0. Therefore, magnitude of A cross B is 0. For anti-parallel, sine 180 is 0. So magnitude of A cross B. Thus, two vectors A and B are parallel, anti-parallel or collinear if the magnitude of cross product is 0. The magnitude of vector product of two perpendicular vectors is maximum. Magnitude of A cross B, AB sine theta. If theta is 90, then sine 90 would be 1. So A cross B is AB, and that is the maximum value. So parallel, anti-parallel, collinear, magnitude of the cross product is 0. But when they are perpendicular to each other, then the magnitude of cross product is maximum and equal to the magnitude of vector A and vector B. Now let us see what are the applications of the cross product. Using the cross product, I can calculate area of the triangle. I can calculate area of the parallelogram. Now I imagine a triangle here. This is A vector, this is B vector, H is the height of the triangle. So how do I calculate area of the triangle? Half base into height. Base is given by length of the A vector, height is H. Now in this triangle, I can write sine theta, it would be H upon B. That is perpendicular upon hypotenuse. So H would be equal to B sine theta. I can substitute here. So it would be half magnitude of A cross B. So area of the triangle is equal to half magnitude of cross product between A vector and B vector. We can also calculate the area of a parallelogram with the help of cross product. Let A vector and B vector form the adjacent sides of a parallelogram. Here is A vector and here is B vector. So what is area of the parallelogram? Base into height, that is A times H. There is a triangle here. You can calculate sine theta. It would be H upon B. So H would be equal to B sine theta. So I can substitute A into B sine theta would be equal to magnitude of A cross B would be same as magnitude of B cross A. So area of parallelogram is given by magnitude of A cross B. That is magnitude of the cross product between A vector and B vector. I can always determine the law of sines in a triangle using the cross product. So here we have a triangle, one side represented by A vector, another side represented by B, and C represents the third side taken in opposite order. So according to triangle law, A vector plus B vector is equal to C vector. Now what I do is take the vector product of both sides with A. So I can write A vector cross A plus B is equal to A cross C. A cross A plus A cross B would be equal to A cross C. The cross product of the vector with itself would always be 0. So here we write A cross A as 0. Now when it comes to A cross B, then I need sine of the angle between them. This is A and this is B. The angle between them is 180 minus gamma. So I write here as 180 minus gamma. Between A and C, this is A and this is C, and the angle is beta. So I write it here as AB sine of 180 minus gamma, and sine of 180 gamma is second quadrant. All conversions are positive, so I obtain sine gamma. Then sine beta. A cancels on both the sides. So I get B sine gamma would be C sine beta, which can be written as B upon sine beta is equal to C upon sine gamma, and that is equation number 2. Now I can take the vector product of same equation number 1, that is A plus B plus C with B vector. So I'll obtain B vector cross A plus B would be equal to B cross C. So can be written as B cross A plus B cross B and B cross C. This becomes 0. This would be AB sine of 180 minus gamma. This is BC sine of 180 minus alpha. So I get A sine gamma would be C sine alpha. Can also be once again written as A sine alpha is equal to C sine beta. If I combine two equations, second and third, I obtain A upon sine alpha would be equal to B upon sine beta would be equal to C upon sine gamma, and this is called law of sines in a triangle. Then there is something called the Lagrange's identity. What does it say? Magnitude of A cross B ka whole square plus A dot B ka whole square would be equal to magnitude of A ka square into magnitude of B ka square. Let's prove it. So A cross B ka whole square plus A dot B ka whole square would be A square B square sine square theta, A square B square cos square theta, and sine square plus cos square would be 1. So this would be A square B square, can be written as magnitude of A ka square into magnitude of B ka square. Now let us calculate vector product in terms of rectangular components, that is in the Cartesian coordinate system. Let us select two vectors, I of Ax plus j of Ay plus k of Az, and B as I of Bx plus j of By plus k of Bz. A cross B can be written as A vector cross B vector. Again, if I multiply, I will be obtaining the 9 terms. Here I cross I would be 0, J cross J would be 0, and the reason is I cross I means 1 into 1 sine 0. Since sine 0, here sine 0 would be 0. So I will obtain the 3 terms as 0. What is I dot j? It would be k. I dot k would be minus j. That is what we have written here. So this term becomes 0, this term becomes 0, and this term becomes 0. All other terms you can write I cross j as k. I cross k will be minus j. So all the terms can be written and readjusted in this format. So I will obtain A vector cross B vector would be Ay Bz minus Az By I cap minus j Ax Bz minus Az Bx plus k Ax By ay bx. Now I can arrange a I j k. If I move in this direction, that is anti-clockwise direction, then I cross j would be k. Similarly, j cross k would be I, k cross I would be j. If you change the direction, I cross k, it would be minus j. So either of the two techniques could be utilized to calculate the cross product. Another method that comes into existence for calculating the magnitude of the cross product is through the determinant method. Here I, j, k, coefficient of I cap ax, j cap ay, and coefficient of k cap is az. Then in case of b vector, I cap has a coefficient bx, jy has by, and k cap has bz. It could be written as I cap. When you take I cap, you leave this column and this row. So what are the remaining things? Ay, az, by, bz minus j. Then you have to leave this row and this column. So the remaining part is ax, az, bx, bz. And in case of k, then I can utilize this four quantities as here. So ay, bz positive minus by, az negative. So ay, bz minus az, by minus ax, bz minus az, bx plus k ax, by minus ay, bx. So you have the same expressions at both the places. These are the two different ways by which you can express vector product in terms of Cartesian coordinates. Now let us check what we have learned through examples. I cap and j cap are unit vectors along x and y axis. What is the magnitude and direction of I cap plus j cap? What is the component of I, a vector along b vector? So we have b vector here as I of bx plus j of by, which is given as I cap plus j cap. So what does it mean? Bx is 1 and by is 1. So what is the magnitude of b vector? Under root of 1 chi square plus 1 chi square, that is under root 2. The direction of b vector, because every vector can be written in terms of magnitude and its direction. So direction b cap would be equal to b vector upon b, that is I cap plus j cap upon root 2. This defines the direction of b vector. And what is the magnitude of it? That is equal to root 2. Now I need to calculate component of a vector along b vector, and that is a cos theta. Would be equal to a dot b upon b. A vector given by 2i cap plus 3j cap, its dot product with I cap plus j cap, and magnitude of b is root 2. So 2 into 1, I dot I would exist, j dot j would exist, and all cross terms would be 0. So that gives me 5 root 2. Now this gives me magnitude of a component of a vector along b vector. So I need direction of b vector, which is I cap plus j cap on root 2. So component of a vector along b vector would be 5 upon root 2 b cap. And what is the value of b cap? I cap plus j cap upon root 2. Now another example here. Find the angle between the vectors a and b. How to define angle? Cos theta would be equal to a dot b upon ab. So a vector is here, b vector is minus 2i cap, minus 2j cap, and minus 2k cap. What would be the magnitude of a vector? Under root 1 chi square plus 1 chi square plus 1 chi square, and here under root 2 chi square plus 2 chi square plus 2 chi square. So a dot b, I dot I would exist, I dot j would exist, and k dot k would exist. So I'll have minus 6 upon 6, and that is minus 1. Cos theta is cos pi, then it has a value minus 1. So what is the value of theta here? 180. So using the concept of dot product, we are able to estimate what would be the value of angle between the two vectors. Another example here. Find the value of integer m so that vector a may be perpendicular to the vector b. Now, when I was discussing perpendicular vectors, we said the vectors are perpendicular if their dot product is 0. That is, for the vectors to be perpendicular, a dot b must come out to be 0. The value of vector a is 3i cap minus 2j cap plus k cap, and b is 2i cap plus 6j cap and m k cap. So written here. I dot I would exist, so I'll have 3 into 2, that is the first term, minus 2 into 6 and 1 into m. 6 minus 12 plus m is 6, so m would be 6. To make vector A perpendicular to vector B, the integer m must have a value 6. If it has a value 6, then A vector would be perpendicular to B vector. Now, what does this example say? Find a unit vector perpendicular to both A and B. While discussing the cross product, we said A vector cross B vector would be magnitude of A cross B into n cap. And what is n cap? It's a unit vector perpendicular to both A vector and B vector. So I am supposed to first calculate A cross B, and that I do by determinant method. So I cap, then I ignore this row and this column. So I get minus 1 plus 1, 1, 1 here, minus j plus k. So I minus 1 minus 1 minus j 1 minus 1 and k, that is 1 plus 1. This factor becomes 0. So what do I get? I get A cross B as minus 2i cap plus 2k cap. So what would be the magnitude? Under root 2 chi square plus 2 chi square, that is 2 root 2. Unit vector n cap would be A cross B upon magnitude of A cross B. So minus 2i cap plus 2k cap upon 2 root 2. So this is minus I cap plus k cap upon root 2. This is the unit vector which is perpendicular to both A vector as well as B vector. Let us pick up another example here. For what value of lambda will the vector A given by 2i cap plus 3j cap minus k cap and B minus 4i cap minus 4j cap and minus lambda k cap be parallel to each other? So A vector will be parallel to V vector only when their cross product is 0. So let us find out cross product of A and B. On the right hand side, it must be a 0 vector. So the three components are 0. Cross product calculate करिए. Calculate करने पे I'll have I cap minus 3 lambda minus 6 minus j cap minus 2 lambda minus 4 and k cap is equal to this one. So I cap here minus j cap, this term becomes 0. So if LHS and RHS are supposed to be equal, then coefficient of I cap must be equal on both the sides. So I put minus 3 lambda minus 6 should be equal to 0. So lambda would be minus 2. If lambda is minus 2, then A vector would definitely be perpendicular to B vector. Another example here for the vector multiplication. It says under a force 10 I cap minus 3 j cap plus 6 k cap Newton, a body of mass 5 kg moves from position R1 to R2, defined by the position vector 6 I cap plus 5 j cap minus 3 k cap meter, to R2, that is 10 I cap minus 2 j cap plus 7 k cap meter. Find the work done. Work done is given by F dot dr, and dr means change in the position, that is R2 minus R1. So force is 10 I cap minus 3 j cap plus c cap. R2 is 10 I cap minus 2 j cap plus 7 cap, out of which you have to subtract 6 I cap plus 5 j cap minus 3 k cap, which gives me the resultant 4 I cap minus 7 j cap plus 10 k cap. In the dot product, I dot I would exist, j dot j would exist, and k dot k would exist. So 10 into 4 plus 3 into 7 plus 6 into 10, and that gives me 121 joule. So 121 joule would be the work done by the force in moving an object of mass 5 kg from the position R1 to position R2. Hope the multiplication of vector through dot product and cross product you are able to understand very clearly. So the students, if you are enjoying my videos, then you are requested to like and subscribe the videos. You are supposed to like the videos, subscribe the channel, and you can press the bell icon to obtain the notifications at the right time. Now let us pick up another important topic of the system, that is relative velocity. Now what is relative velocity? It comes into existence when there are two objects which are in motion with respect to each other. The relative velocity of a body A with respect to B when both are in motion is the rate at which the body A changes its position with respect to the body B. So relative velocity of A with respect to B, VAB, it is VA minus VB. Relative velocity of B with respect to A, it is VB minus VA. And if you observe both of them, both are equal in magnitude, opposite in direction. Therefore, I write VAB is equal to minus of VBA. Both are equal in magnitude, opposite in direction. How do I find VAB? To find VAB, a velocity minus VB equal and opposite to that of B is superimposed on both A and B. As a result, B comes to rest and A has new velocity, which is VAB, which is found by vector addition. So what you do? You superimpose minus VB on both velocity of A and velocity of B. So velocity of B, it becomes 0. So B, the object, comes to rest. So VAB is VA plus minus of VB, which can be written as VA minus VB. Now let us try to understand the concept of relative velocity with certain examples. A man going due east with a velocity of 3 km per hour. Rain falls vertically downward at a speed of 10 km per hour. Find the angle at which he should hold his umbrella so as to save himself from the rain. So Vm represents the velocity of man, Vr representing the velocity of rain. So man is going due east. Man is going due east and the velocity is 3 km per hour. Rain is falling vertically downward with a velocity Vr. Now I am supposed to calculate what would be the relative velocity of the rain with respect to man, because that is the direction in which the person is supposed to hold his umbrella so as to save himself from the rain. So see, we need to calculate velocity of rain with respect to man, velocity of rain minus of Vm, that is Vr minus Vm. So this Vm, so I can write negative of vector, so I write it as minus Vm. So there are two vectors and their resultant would be given by the diagonal. So this vector can also be written as minus of Vm. So these are the two sides taken in order. This would be the third side taken in opposite order. So umbrella has to make an angle theta with respect to the vertical. So tangent of theta would be equal to perpendicular upon the base. So Vm upon Vr, 3 upon 10, that is 0.3. So theta is tangent inverse 0.3. Looking into the log tables, we find it the angle as 16 degree 42 minutes. So the person, to save himself from the rain, has to hold his umbrella 16 degree 42 minutes with respect to the vertical. Let us come to another example. A ship is streaming due east at 12 meters per second. A woman runs across the deck at 5 meters per second in a direction perpendicular to the direction of motion of ship towards north. Calculate the velocity of women relative to the sea. So I need to calculate velocity of women with respect to sea, represented by VW, W for women, and C can be written as velocity of women minus velocity of sea. Now what is the velocity of ship with respect to sea? It is velocity of ship minus velocity of sea. Velocity of women with respect to ship, it is velocity of women minus velocity of ship. Now what I need? VW minus VC. I need this term and this term. So add both of them. So V ship cancels out. So I add both the equations and what I get is V ship with respect to C, VW with respect to C is VW minus VC. That is velocity of women with respect to C. I need to calculate this. So this would be under root of a chi square plus b square plus 2ab, and the angle is 90. So cos 90 would be 0. Under root of 12 chi square plus 5 chi square, that is under root 169, 13 meter per second. What is the direction of the relative velocity? Given by the angle alpha. So angle alpha is here 5 upon 12. So angle alpha is tangent inverse 5 upon 12. A swimmer who can swim in still water at a speed v wants to cross a river. In what direction should he swim to cross the river in least possible time and along the shortest distance? Let us first take the time of shortest time. Here, this is the velocity of the swimmer, Vs, making an angle theta with AB. The effective velocity for crossing, because Vs I can take a component here which would be equal to Vs cos theta. So Vs cos theta velocity would be equal to distance upon time. What is W? The width of the river. And what is the time taken to cross the river? T. So I can write T as W upon Vs cos theta. Now you have to make time T minimum. For that, cos theta has to be maximum. And the maximum value of cos theta is 1. When will I obtain? When theta is 0. So the swimmer should swim in a direction perpendicular to the river to cross the river in shortest interval of time. That is understandable. Shortest distances are the perpendicular distances, and therefore the time taken would be minimum. Let V be the resultant velocity of Vs, that is velocity of the swimmer, and velocity of the river. So here let us go to the figure back. This represents velocity of the swimmer. This would represent velocity of the river. So what will be the resultant velocity? V. These are the two vectors in order. Their sum would be represented by the third side taken in opposite order. So come back here. So V would be equal to under root of Vs chi square plus Vr square. The third term would be 0 because cos 90 is 0. Tangent theta would be Vr upon Vs. What would be the time to cross the river? It would be distance upon speed. The distance travelled in the downstream, let us see. The distance travelled in the downstream, BC. So let us pick up here, BC. So tangent theta would be BC upon AB. And BC is VR and AB is Vs. AB is the width of the river. So I can write BC as VR into Vs into AB, and AB is W. So the distance that is travelled downstream is equal, given by this relation. So remember this relation also. It is distance travelled in downstream. Now the second possibility, crossing the river along the shortest path. Along the shortest path, the swimmer moves in the direction of resultant velocity V. So the swimmer tries to swim in this way, the river current is moving in this direction, and V is the resultant velocity. So V would be given by under root of Vs chi square Vr chi square plus twice Vr Vs. And what is the angle between Vr and Vs? This is the direction of Vr and this would be the direction of Vs. So if this angle is theta, this is bound to be theta. This is 90 minus theta. So this angle would be 180 minus 90 plus theta. So this angle would be 90 plus theta. And that is why I write cos 90 plus theta. Cos of 90 plus theta is minus sin theta. Second quadrant. So I'll get Vs chi square minus Vr chi square minus 2 Vr Vs sin theta. Sin theta is Vr upon Vs. That is what I substitute. Then Vs cancels here. It is minus 2 Vr chi square. So I'll obtain Vs chi square minus Vr chi square. Now calculate what would be the time to cross the river. T is equal to width upon velocity. So width is W and the velocity is under root Vs ka square minus Vr ka square. So students, you must have been able to grasp the basic concepts of vectors. Hope the concepts of vector are very clear to you all. If you have understood vectors, then you are requested to like the video and subscribe my channel and press the bell icon button so as to obtain the notification at the correct time. Thank you all. Meet you next time in the next video. Okay, goodbye.